Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll learn how to solve rational inequalities. So these are similar to the quadratic inequalities that we did a couple videos ago because the rules for products and the rules for division, quotients, are the same when it comes to sign. So when we build the sign chart, it's really going to be quite similar. There's one really big difference here though, and that is that no critical value from the denominator can be included as a solution. And the reason for that is that the critical values coming from the denominator make the denominator zero. We know that division by zero is undefined, and so the expression's undefined at that point and you can't have a solution where it's not defined. So whether there is an equal sign in the inequality or not, the critical value from the denominator will never be included in the solutions. As far as the numerator goes, it depends on the sign that we have. So in this first one, where we have it simply being greater than zero, we're not going to include the numerator either. But if I look ahead to the next problem, number 12, I see that less than or equal to sign. That tells me that the critical values from the numerator are included, but the ones from the denominator still will not be. Okay. We need to find the critical values from the numerator and the denominator. Here in this rational expression, the numerator and denominator are linear expressions. The critical value from the numerator is x equals 9. From the denominator is x equals negative 4. So I'm going to start with a number line. 9 and negative 4. Break this number line into three pieces. I'm going to pick a test point to the left, negative 5, one from the middle region, 0, and something to the right of 9. Let's go with 10. So the test points are negative 5, 0, and 10. The two factors that I'm working with are x minus 9, the numerator, and x plus 4, the denominator. And I want to figure out, is it greater than 0? Well, again, the numbers that are greater than 0 are positive. So I'm looking for a positive quotient. When I substitute negative 5 in, negative 5 minus 9 is negative. So that's a negative numerator. Negative 5 plus 4, that's a negative 1. That's also negative. So I have a negative numerator, a negative denominator. When I divide those, I get a positive result. That's a solution. So negative 5 is a solution, and that means that everything in that interval is a solution. Right? If I had picked negative 6, negative 7, negative 300, they all would have worked. When I substitute in 0, 0 minus 9 is negative, but 0 plus 4 is positive. Negative divided by positive is negative, not a solution. Substituting in 10, 10 minus 9 is positive, 10 plus 4 is positive. A positive number divided by a positive number is positive. That's a solution as well. And I'll shade that region. Because the endpoints were not included, I'm going to use a round parentheses there for each. And so our solution set in interval notation is negative infinity, comma, negative 4, both with parentheses, u for union, adding on a different interval, parentheses 9, comma, infinity, parentheses. Now, I used the sign chart. I could have just plugged in and tried to figure out what they were. For example, if I substituted negative 5, I would have had negative 5 minus 9 over negative 5 plus 4. That is negative 14 over negative 1. Negative 14 divided by negative 1 is positive 14, and that is greater than 0. So I could have done the arithmetic as well. I just think the sign chart has a little more finesse to it. Right. Let's take it up a notch. In problem 12, the numerator and denominator are quadratic. By the way, one important thing here is that we're comparing an expression, a rational expression, to 0. That means that I can start looking for my critical values right away. In the next video, we could have the same exact expression, except it might say less than or equal to 1. That is a much more complicated problem because I need to get it equal to, I need to be comparing it to 0 first. And that means I'm going to need common denominators and all of that fun that goes with it. So that's a much different problem. We'll tackle that in the next video. When I have it compared to 0, I can find the critical values. And here, I can find them all by factoring. That numerator, x squared minus 5x minus 14, is the same as x minus 7 times x plus 2. And the denominator, x squared minus 25, that's a difference of squares. That's x plus 5 times x minus 5. And I'm still looking for all of that to be less than or equal to 0. The critical values are positive 7 and negative 2 from the numerator. Those are going to get square brackets when we're done because those are included as solutions. In the denominator, I get x equals negative 5 or x equals 5. Those two are not included as solutions. They're going to get parentheses because, again, those two values make the denominator 0 and the expression undefined. So let's take a look at the number line here. 0 in the middle. My positive critical values are 5 and 7. My negative critical values are negative 2 and negative 5. And one thing that I like to do, even though I'm not going to use them in my final result, is I'm going to put open circles where the ones from the denominator are. That's going to remind me not to include those as solutions. But you could put a regular dot at 5 and 7 to remind yourself that those are included. From the numerator, with an equal sign, those are good. From the denominator, they're never included. Right. These 4 critical values break the number line into 5 intervals. To the left of negative 5, we can use negative 6. Between negative 5 and negative 2, we can use negative 3 or negative 4 or negative 3.5, whatever you want to use. Between negative 2 and 5, I'm going to use 0. Between 5 and 7, I'll use 6. And to the right of 7, I'm going to use 8. So those are my test points. Negative 6, negative 3, 0, 6, and 8. My 4 factors. And I'm going to treat them as if this was a product from this point forward, because the rules, again, for signs, whether you're talking about multiplication or division, it's still the same. If you have an odd number of negative signs, the result is negative. If you have an even number of negative signs, the result is positive. My factors are x minus 7, x plus 2, x plus 5, and x minus 5. And because I'm looking for this to be less than or equal to 0, I'm looking for negative results. All right, let's start at the top. Negative 6 minus 7, that's negative. Negative 13. Negative 6 plus 2, that's negative. It's negative 4. Negative 6 plus 5 is negative 1, which is negative. Negative 6 minus 5 is negative 11. That's negative. So I've got 4 negative factors here. Pairing them up and canceling them out, this is going to be a positive result, not what I was looking for. So negative 6 is not a solution. That means that there's a good chance that negative 3 is a solution, because they often alternate, but it's not necessarily true. Let's check it out. Negative 3 minus 7 is negative 10. Negative 3 plus 2 is negative 1. Same as the first one. Here's where the difference shows up. Negative 3 plus 5 is positive 2. So that's the only factor that's different than the first test point. Negative 3 minus 5 is also negative. Now I've got 3 negative factors and 1 positive. That result is negative. That means negative 3 is a solution. And that means that I can shade in that interval on my number line. Again, that's going to be a parentheses at negative 5 and a bracket at negative 2. Because negative 5 came from the denominator, negative 2 came from the numerator. Let's try 0. 0 minus 7 is negative. 0 plus 2 is positive. 0 plus 5 is positive, 0 minus 5 is negative. Two positive factors, two negative factors, the result is positive, not a solution. If we try 6, 6 minus 7 is negative, 6 plus 2, 6 plus 5, and 6 minus 5 are all positive. So one negative factor, three positives, that's a negative result. That's a solution, so 6 is included. Shade between 5 and 7. 5 gets parentheses, 7 gets a square bracket. How about the last test point, 8? 8 minus 7 is positive, 8 plus 2, 8 plus 5, and even 8 minus 5. All four of those were positive. Four positive factors, the result is positive, not a solution. So those two intervals from -5 to -2 and from 5 to 7, that's where my solutions are. In interval notation, parentheses, -5, comma, -2 with a bracket, union, parentheses 5, comma 7, bracket. All right, that's it for rational inequalities where the rational expression is being compared to 0. In the next video, we'll see what happens when that number is not a 0.